All right, so presentation today, because we get the survey results back from the previous session from 2 months ago. The previous session that I had, had 3 different things that most of the users were looking to have being presented. Now, obviously, all of those users are not here in this session. So these were the things that they had come up with either being the title block and their relationship to component numbering and how that worked in the software, or making a line diagram symbol and how to use it, what that would be for in the software, or making cabinet footprints, which is basically your 2D cabinet layout, how to make those symbols and then use them in the software. So if one of those 3 topics is what we'd like to do, then great. If not, I can present something else. It doesn't matter to me. So this software is set up to be extremely user-friendly. So as you can see over here on the left-hand side, it kind of works the same as what you would see like in Windows, in your Windows Explorer, when you're looking at subdirectories and stuff like that. You can set up all of your software to be organized however you want to organize it. If you want those extra subfolders so that you don't have 50 drawings that you're having to search through, you can actually find it based off of a specific folder. And yes, you can embed folders into folders, and so you could have a PLC folder and then have inputs in one subfolder of that and all along the line. But the thing that's cool about this is as you are developing your schematic, so here's a standard schematic. And this schematic, as I design it, it is picking up the numbering that I have already formulated inside the software. So it's picking up all of my global standards that I am wanting it to follow. Because of that, not only is it identifying all of those numberings, but it's capturing everything. It knows everything that I am trying to accomplish. With this specific disconnect here, this symbol is just a representation of the disconnect itself. It physically can have multiple different types of representation. It could have a from to list to know where every pin is connected and how it gets connected to each other device. It can also have what we call a line diagram, which we'll look at that here in a minute, which is more of a pictorial format for those people that have never seen electrical prints before. They can look at these prints and say, oh, okay, at least I understand how it's supposed to be connected, maybe not necessarily the details of it. You also represent it by adding specific manufacturers. So you add a manufacturer, and then the software is also picking up how it's getting connected electrically for you. So you can determine all of this. When doing so, the software through SQL is then going to manage the fact of how it is being placed. So notice here, I have it that I am using this type of icon here on sheet 5 at row 3. The SQL is picking that up. At the same time, it's also picking up that I'm using a 3D model in my assembly. So with that 3D assembly now, I can put that into my overall mechanical assembly, but it's going to have all of the intelligence and metadata from my schematic, because as you know with SolidWorks itself, the 3D model doesn't have anything other than the custom properties that you design into it. But if you design it 10 times in a project, if you wanted to know that this is disconnect number 1 or disconnect number 10, you have no way of determining that without going through some additional steps in SolidWorks and breaking the references a bit in order to tell it that it's a separate instance, where normally it would just say that it's that one 3D model. By doing it this way, the SolidWorks electrical is now capturing that device in what we call a component library. So I'm going to just look for that library here, or look for that component here, by simply typing in 0614. When I do, notice it automatically picks up everything that is 0614 because of that SQL. Here now, again, I have that same list, and here's the 3 places that it's being used, but I can also go directly to the browser on my left, and it will automatically open up exactly where this is located. Now, why is that important? SolidWorks Electrical sets things up so that you can work in an assembly type environment. So what we would call a location is actually a sub-assembly. Because of that, say a vehicle, one of your toys, is that full assembly of everything already assembled. The harness might just be one little piece to that, but it might have different connectors in different locations that different people might be working in SolidWorks to assemble. You can actually place those little pieces, the battery, the starter, those types of pieces in those specific locations so that when somebody is then looking to create that sub-assembly section, they would have just that list of components electrically that need to be placed. So it then builds upon itself as you are then taking it one step further. So that's exactly what I have here was this 3D model. I'm going to look at this line diagram though, just to show you the same thing. Here is what we call a line diagram. This is that same representation of that disconnect, but in a pictorial format. Now what's nice about this is an entire pallet conveyor. You can see how everything works. You can see that I have a PLC that's connected to a transformer, that's connected to a disconnect, but then is hooked up to the main disconnect. You can see that there are terminals here that are between the motor starter and the motor. That type of information for someone who's never worked with electrical before can give them some added benefits. One of the benefits that you have as a designer, though, is that all of these lines are still intelligent. They are still cables. So here, this specific unit, this is my entire terminal strip. I'm just going to go ahead and open up this window to make it a little bit bigger so I can see my entire list of terminals. I have 16 terminals there. Because of that, knowing that I am now connected, yes, I could find it here, but if I click on that, you can see how it flashes and shows me where it's physically connected. So I don't have to think about it, but yet that detailed cabling is embedded in the background to still be able to be used. You can design this way rather than design through a schematic. And that's more for those advanced users that are looking for doing some additional things. One of those additional things might be, as Mark can attest to, hydraulics and pneumatics can be really easy to draw the pictures and add those the pipes to. Same type of situation. Another one that is very much used would be communications. When you are dealing with all those Ethernet wires, you can place them on like a floor plan layout for where the specific devices are at and just show the cable routing in a 2D floor plan to be able to give people ideas as far as what's getting connected to what. A splitter might be split in between 8 different areas, and you can tell them what port. You can give them IP addresses, because all of that type of information is being handled by the SQL. So it's just another field that you would place in the component here. So let me go back to that 614 disconnect. If I am looking here, this disconnect, the component itself is the entire operation of this device, whether it be a manufacturer's part, say a Schneider Electric disconnect, but think about that Schneider Electric disconnect. If it's a disconnect, and maybe it's a main disconnect, you've probably got a threaded rod, you probably have a bracket. On the outside of the panel, you've got the handle switch, and those are all extra parts you have to purchase to get that operation to work, you can add all of those parts right here. What you get is a 1-to-1 ratio between the manufacturer part that you assign and a 3D model. So for every manufacturer's part you assign to a device, a 3D model is also present for your assembly to be able to place as well. Any questions so far?
Sounds pretty good.
Victor? No? Okay. So this is the type of work that we're talking about. So here we have this device. This device, you can get into the device itself, and the device allows you to have information embedded, all that extra metadata, including circuits and terminals. Now notice here I have a height, width, and a depth, and I also have a 2D footprint. I could have just as easily assigned a 3D model to that device. If I don't have one, the software is going to pick a generic device for me and then just reestablish the size based off of those requirements. So you can take any 3D model and you don't have to actually assign it, but yet you can still use it in the 3D environment. This also has a number of other areas that can be used, including this user data field and the translatable data fields. We've got a total of 40 fields available for extra use that you can designate to have any extra metadata that you are wanting in the library. Now, once you assign it to a specific component, what you end up getting is you get the mark and data information here, but this also has another 40 fields. These 40 fields are specific to this component. You can have the 40 that are in the library from the manufacturer's part, but then you get these. This is where I would now set up a field called the IP address, or any other information that you are wanting. Give it a subnet information. All of those could just be placed right here, and you could just type them in. It would be specific to that device. Okay? So that's the type of information that we're talking about. Well, how does that end up getting used? Well, as you know from the software here, as I'm developing this, if you've worked with any type of CAD tool before, it's just a matter of that the minute that you are drawing, you can draw anything. And it's based off of the information you have up here. This information then accesses libraries that are already in your software. What's nice is that because you're working with libraries, you develop something once, and it is now available for use for not only you, but anyone else that's attached to that system.
Cool.
So you don't have a whole lot of remaking of things. You can get to those global standards because you can create a library that is specific to you, specific to your company, saying you only use this set of symbols. And so if I were to go ahead and say insert symbol here, what it's going to do is go directly into my library. And consider the way these libraries work is I've got a huge bucket. Because I've got that huge bucket, now I want to make a smaller bucket. So I'm basically going to filter out all the stuff that I am wanting to keep that, but to get rid of all the other stuff. So we have these things. One is called a classification. That is one filter, but there are a number of different filters here that we have that will then allow you to have a smaller bucket of parts. So if I say any here, this is my entire library. So my entire library has 2,765 parts. Well, I sure as heck don't want to sort through that to figure out what I'm looking for. So if I'm looking for something specific, if I know that it's got a number 3 in the description, I can just type in the number 3. And it will then sort down my filter to a smaller number. So now I only have 307 parts that I am looking at. And it will give me everything, including PLCs. I have hydraulics and pneumatics because, of course, I can also do hydraulics and pneumatics in the software. It's just a schematic. It doesn't matter what type of schematic I'm trying to do. But no, it doesn't do PBC or PCB. PCB is a separate software that we do have as well, which is very similar to Altium Designer, except that you can bring everything into SolidWorks. And I'm sure with PCB or OrCAD or Eagle or whatever you've developed in before, you've had issues with creating those contours of those boards, especially with a rounded corner or a hole because you're having to draw lines. SolidWorks, then, if you push the board into SolidWorks, you can now instead make the contours using fillets and arcs and ellipses and holes without that issue, and then push the board back into PCB or Altium and have the capability of now creating that board outline very quickly. So just as a side note.
Okay.
Just as a side note.
That'd be good to stencil around a bunch of objects.
So
Yeah,
to do that, would you like, say you already created your schematics,
Yeah.
and now you transfer your finalized schematics drawing to PC board.
Mm-hmm.
Without placing all the components strategically, would you then send it over to SolidWorks to custom shape your board?
You could do it
And
either
then
way.
bring it back and then place all the components strategically?
You could do it whichever way you want. You could have SolidWorks build just the board first, give you an outline for you to already work in, because of course you could select and convert the entities into a sketch that would be the board outline. You could have it do that first and then push it to Altium or PCB. And then you could create that schematic, or you could do it concurrently. It's 6 of one, half dozen of the other.
Okay.
And it's one of those things that you can push and pull back and forth without too much concern whatsoever.
Okay.
It's actually really cool. Anyway, so back with this here. So as I select with my filters, I get different pieces and parts. Now, here is a symbol that I have created. No, where is it? Right there. Here is the symbol that I have created that is a schematic symbol, but it's also a line diagram symbol. Now, why am I talking about that? Well, this symbol, if you've ever built a harness before, one of the biggest problems you've got is that people put the wrong pin to the wrong spot because they don't know, based off of the front or the back, which way pin 1 or pin 4 is. Because, of course, they don't have their readers.
Ouch.
I'm one of those. Hey, you know.
Yeah, I just.
Yeah. Point being is, so I give you can have a picture of this device, plus you can have an actual from to list built into the symbol. So all I'm going to do right now is just copy this real quick, and I am going to copy with an insertion point, so that way I am placing this. Ooh, you know what? I don't want to do that. I'm going to do that copy insertion point, but I'm going to grab this connection point up here. And then I'm just going to place this a second time. And we'll just place that right here. Notice that the minute that I did, it's picking up the fact that it's knowing that this is on row 10 and row 5. So here's row 5 and
like
here's
a
row
flag.
10. It's actually picking up that information on these devices. So it's a separate entity and knows it even the minute I do a
Yeah.
copy paste. What I can now do is simply go ahead and start connecting with wires. So wires, not only can I have a color, but I can also have a bend radius. I can have the actual section of the gauge of the wire, so that when I take it to 3D, I now have that capability of routing those wires, and it already has the information available, knowing what it needs to do for the harness. So here, I am just going to go ahead and select this wire, but I'm going to just start by just connecting up these different pins. So let's see here. That's good. There we go. There's one. And I am going to just cancel or finish this command right here. Come on. Oh, I guess I didn't grab that one quite good enough, did I? I'm going to grab this device and actually place that on the grid. Make sure my grid is on. And turn off ortho. Because this way I can snap to the grid or snap to a specific wire. Notice what happened. The minute it grabbed that wire, it actually knew what the destination was for the other device, and vice
Oh,
versa.
and okay.
So if I go ahead and add a manufacturer to this part now, so let me just go ahead and grab a part, go to that component and grab a manufacturer. It knows right now that it has 4 pins that it needs. I can search for
Okay, so
those.
in the manufacturer stuff, it has all the general stuff for that part, but then in the marks and data will have that specific one. with it. Okay,
Exactly.
okay. So those two are different in the marks and data, but the same in the manufacturer.
Correct.
Did you see those things turn from red to green?
No, does that mean they have a
If I grab, as I grab different
now.
devices,
Okay.
it will tell me, notice here, I've grabbed one that says power female, but I need power male.
Okay.
So, as I select, it will find what it needs based off of the symbol that I've drawn, and will allow me to then create and add that specific part. So when I do, you'll now see that 1, 2, and 3, and 4 show up on the device as well as the part number. And it shows up with the pin numbers as well. All right, and so if I do the same type of thing up here with this device, and grab that manufacturer. Again, so if I select anything, as I select it, it's going to give me what it needs or what it doesn't need. So I just grabbed an 8-pin. Obviously, that could satisfy this if I'm breaking apart a connector, but for this one I want specifically 4 pins. So I'm going to filter this down to a 4-pin and just grab a part, and there we have a different part number. And say select. And so now I have pin 1 is going to pin 3, and it even tells me that here, that it is going to pin 3.
Okay, so it says this specific part, this specific pin.
Yep. And now what's even better is that I can take this one step further by numbering the wires. By doing so, what it will then do is pick up the wire number and place it also into that connection label, which is my from to list. So as I make changes, it will then also add those changes to and give me a constant feedback. Now, those 2 devices, if I look, I want to just check here with those 2 devices, what did it create as far as the manufacturer's part? Do I have a 3D part assigned to it? No, but I have a height, width, and depth. Okay. To take this into the 3D environment now, I would simply go ahead, and one thing that's nice about the SolidWorks is you can create what we call a process of these SolidWorks sub assemblies. It is just a quick link to take it directly into SolidWorks. So I'm going to go ahead and open up SolidWorks. Let me just go ahead and grab the SolidWorks piece here. Let's see if I can get to it without. Nope, I can't get to it from there without closing that. So I'm just going to go ahead to my SolidWorks here. And in SolidWorks, Electrical has a 3D package. It is a separate package that you buy, but it has an add-in for SolidWorks. And what this is going to allow us to then do is take that schematic one step further. And what it did is here over on my right, I now have the capability of being able to see that same project that I had in schematic. I can see it here in my 3D environment, and this is just telling me, hey, somebody else is using it, because of course you can have those concurrent users. But I can actually preview my entire project right here. And so I have that capability of that, seeing those line diagrams, being able to preview it or whatever I need to do. I can't make changes to the schematic
This
here.
is a read-only.
This is a read-only, but over on my other side, let me just go ahead and open up this sub-assembly here by saying open, and what it's going to do then is bring in a mechanical sub-assembly, but also those electrical components that we've assigned to that area. Now, once I do that, yes, don't show that again. I don't care about my vault at this moment. I also have PDM on my system. So this is going to open up. Now, the same devices that I had here, let me just open this up a little bit further so you can see it. There's those 2X components
You
right
measured
there.
it in.
They're already there. I didn't have to do
Because
anything
you
for
put them
that.
on that
I'm
schematic.
sorry?
Because you place them on that schematic, this knows that.
I gave it a component ID. The software realized that that manufacturer's part is a 1-to-1 ratio. Because of that, if I add another device or add a component to that device, it's also going to give me another 3D model. So if I were to go back to schematic and take that device and add a second part to it, whatever that part is, it doesn't even matter what that part is. But if I search and I just grab another part, so I'm grabbing an auxiliary here, we'll just grab a pin, and I'm going to add a pin to that so that I have 2 parts. Okay, so now I see that I have 2 parts here. If I now go back into my SolidWorks, you will see that there are 2 3D models. So for every manufacturer's part I add, there's a 3D model assigned that's available as well. Now, if I don't have them assigned, I can simply just right-click and say, Insert from a file, and go find it. I don't have to have that library fully assigned beforehand. And simply go ahead and say, Insert. So let's see here. What do we have? I have no idea what. I had a Windows reinstall here just recently. So I don't know that I actually can. We'll see what I can find here.
Too hard to
4-pin. I got a 4-pin female. Was it a 4-pin female or 4-pin male?
It was male.
Ah.
Well, I know the bottom right one was.
Yeah, I think they were both male. 4-pin males.
Side note, that doesn't have to be the same person using the SolidWorks tool itself. They can be a
Okay.
completely different part of the building.
Right?
Okay, so
'Cause
you
it
can
can
be
be
doing
all in it.
electrical, they can do mechanical,
Yeah.
and you can see their
Yeah.
changes that they're adding.
Yeah,
immediately.
exactly.
Okay.
So there's the part right there, and as I'm developing that, I'm placing it, and it's also checking it, which also is giving me that additional feedback. But yet,
Yeah.
all of that information for that device, I can simply go to the properties here, and I can see all of that information just like I could in Schematic. So it's that extra metadata that's now happening, that's transitioning back and
And it's
forth between the
consistent
two.
from one, the mechanical and the electrical.
Correct.
It's all the same
However,
database.
Yeah, okay,
yep.
awesome.
Do the hide already inserted. That's my
Hide
fa-
already is inserted. Okay,
That's my
so
favorite.
that's your favorite. All right. So what we have up
It doesn't
here.
sound all that exciting, but
It
I'll
is,
brace
well,
myself.
when you are building, if you think about this, when you are building a panel, so if you are building a panel, that can become sometimes an extreme, come on, give me,
Wow.
there we go, an extreme nuisance when I am building a panel like this size, because now I've got so many of the same devices. And so what I'm trying to do here is build those pieces and parts in that subplate. But now I've got this entire list of, oh my gosh,
It's overwhelming.
overwhelming.
Yeah,
But
okay.
here's what's nice.
Yeah, we're
Anything
digging
that's
through and looking
already
for it.
placed,
Yeah.
I can simply check this button and then look at it a second
These
time.
are just the things you
And
actually
I
need to
have
deal
now everything manageable. Here's what's left
Yeah.
to place. And what's nice is with SolidWorks, you can grab a specific, let's just grab this entire list right here, and place all of those devices at one time. So I'm just going to grab
Watch.
that first one. Notice it's working with SmartMate, so it's snapping to the DIN rail. It's going to ask me what kind of width mate between the devices that I want. So I can simply say 0 or 10 millimeters here. And then tell it to place all of those devices at one time. Now, if I make a mistake, it's not a problem, because all I am doing is placing the 3D model in the assembly. I'm not deleting it from the project. I'm just deleting it from the assembly. So now what ends up happening is if I don't want that transformer here, I can simply just say delete, and all it's going to do is uncheck the box right here when I go ahead and remove that from the list.
That's scary to say delete, but it's just the visual image
Yeah,
from
it's
the
ju-
drawing.
right. It's
Okay.
just the representation of the 3D model.
If you want to know what's really scary is, say you have the mechanical guy puts in the terminal strip, the electrical guy can actually delete those from the project, and you'll see them disappear right from your model.
Yeah,
Cool.
That's why it's was a gold rated product.
yeah. It's actually really cool.
You don't
Yeah.
even
So-
have to like refresh it or something for the
No, it's a
Real time.
dynamic update. It is a
It's all real
dynamic
time.
update.
Hmm.
What time are we supposed to go to? 6:30? Or is it 6:45?
It should be in there. I didn't grab a thing.
It says
5:45 to
6:45. Okay,
Yep.
cool. So we've got 15 more minutes. All right. So as we're placing this, as you know with SolidWorks, only the things that are placed in the SolidWorks assembly are allowed to then show up in the bill of materials.
Right.
However, in Schematic, it doesn't matter if it's been placed or not. If you've designed to it and called it out in your component list somewhere, it will then show up in your bill of materials.
Why?
Because that is automatic. So
Make sure
here,
as you leave nothing
the
out.
SQL
You
will
often
take care
you
of.
often select a lot of parts that you're not going to see over in the 3D world or something necessarily.
Yeah.
Right. So here is a full list of parts. And what's nice about this report or any of these reports is customizable just by adding columns. You can create, remember those extra user data fields that I was talking about?
Yeah.
You can add
40.
those to this report by simply coming in here and going into the properties. And the properties will give you columns where you can actually add those extra columns.
Okay.
So those component here, remember I said the difference between a component? Here are the component user data fields and translatable fields, but there are also the user and translatable fields from the manufacturer. So that's where it's getting all of this information from. So I could simply come in here and click component user data. Oh, let's say, well, you know what, let's not do that. We'll just take those two right there, user data 0 and user data 1, and say okay. And it then just adds 2 more columns to your report. By looking at this, you can then go into the layout to actually see what this looks like. And oh my gosh, look at that. My layout is a little bit bigger than my sheet. Don't want that. So I'm going to come back in here and I'm just going to make a change to this description by the 4 inches that I added. Now by making that 6 inches, it's going to drop it down. And so of course this works the same way up here in the top where
Does it
I
tell
can, you can see that in this layout. The layout
Okay.
shows you what you actually have. And you determine those numbers. Okay, so now I simply could say apply. And I would have a generic report that I could then go ahead and say, generate a drawing. So when I generate a drawing, this is just taking a picture of the SQL, a picture in time, because of course the SQL is a dynamic update. So this is taking a picture in time right now. Come on, let's unclick those and click that one there and say, okay. It is then going to automatically create this report for me, including those 2 extra connectors that I added. So if I go back over here to my Schematic tab and I look at my bill of materials, my bill of materials is laid out, and notice there are those component user data fields, as well as everything that is in the devices. Now notice right there, there's all those AMP connectors that I added.
Yeah.
I didn't have to do a whole lot. I assigned it once, it knew it. I don't need Excel, I don't need a napkin, I don't need to talk with anybody else.
Or even copy and paste the number.
Well, napkin's optional.
Yeah. Well,
Yeah. But yeah, so this type of stuff is really kind of cool. Now, all right, so maybe I don't want this 350687 to show up in this bill of materials. Maybe I don't want them to order that. I have enough pins, I don't want that ordered. I can come back in here to my report, and we have this thing called filters. Now I can simply add a filter, and when I add a filter, I'm just going to call this exclude pins. So in that, what I'm going to do is come over here to the condition, and I am going to look at the part number. So that is giving me a condition of a part number as long as it is not equal to the value, what was it, 350687 there. Then it will be my bill of materials. Everything else will be in my bill of materials, but not that one. And now I get, okay, I will have 2 bill of materials reports. One is customized with a filter, so that this one specifically now shows it without. And you can see it's not here. But yet the original still shows that full piece. So if you have those things like a panel builder, that you would be having a panel made by someone, you might not purchase the DIN rail or the duct or the panel itself. That might be something that they purchase. But you also know for costing purposes how much you're using and how much it should cost. Which of course you can use one of those user data fields to put in a cost per length.
Yeah,
Because
right.
of course the duct and the DIN rail in 3D you get the length. Well, what you also get is the fact that in 3D it will also push back what those lengths are to electric.
Oh, and then you'll have that data.
And then
field
you can
because-
calculate it using the report to actually come up with all of that information. So back over here, I can simply say something like route wires. And if you think of the wires and the amount of wire that it takes to route, and you need it to follow a specific area. Now, one of the things that's nice here is you can exclude communications from your 480 so you don't get attenuation effects or any of that by simply going and using our segregation and segregation manager. But here I can simply go ahead and start plugging away, and the software using the premium routing engine is now going to actually take that thickness of the wire, the color of the wire, the bend radius, and actually route those wires because it knows how to connect them from each spot to each spot. What's nice is that unlike SolidWorks Premium, you can route shortest point to shortest point. It's a drag and pull, no big deal. But if you think about putting it through a harness of a vehicle, and you've got to go through grommets, you've got to go through holes in the vehicle, in the framework,
Right.
go through the lighting.
There's so much
All-
more going on.
It's
That's
so
not gonna
much
give you
more.
an accurate
With
length.
electrical, you can actually create a 3D sketch on your assembly for where the wires should route. So you actually tell it how to route, and then it goes and follows that path to create that route for you
It's rendering
without
one wire
you,
at a time.
one style at a
It's
time.
kind of awesome.
Which is really cool when you think about it. You can create assembly instructions for one type of wire by saying, here's what you need to do. And you can see those
You
yellow,
can almost
every
record
once in a
that.
while you'll see the yellow dashed lines. Those are what you would get if you were doing SolidWorks Premium routing, because it's going shortest point to shortest point. And then saying, oh, wait a minute, I've got to follow a path.
Yeah.
And then it follows the path. These ducts, each one of these
Yeah,
ducts
yeah.
has a routing path in the middle of it. So it knows that it needs to route that harness or that wire along that.
Wow.
And it can calculate fill ratios.
That is pretty. That
Wow.
part's incredible.
That's
Like
all
that.
the
The whole thing.
I know, but I don't even
this
get
is
most
the
of it. Like,
neatest
this makes
things.
total sense to me.
Yes, as
I-
mechanical,
I
that
think
makes sense to you.
perhaps, I don't quite get how awesome it all is because I'm not following it all. But that, like, is very clear.
What's nice about the harnessing, though, is usually harnesses are designed. Someone goes out and measures everything, and then they design the whole nail board for it. And in here, when you're in the electrical project, you actually select which wires and which connectors are going to be part of a harness,
Wow.
and then it'll create that for you. And then you can, and you never had to create the harness in your schematic. You just said these are parts of it, and then it's all done in the
And
3D.
it does that.
Wow.
Okay, that's awesome.
So
In order
Tara,
to get it to work, though, do you have to have all your ducks in a row?
No.
Sorry.
Oh, oh. Yeah,
Oh,
no,
pretty
you
good,
do not
pretty good,
need to have them
pretty
in a
good.
row.
Oh, man.
Perpendicular will still work.
Yes, because that's one of the parameters is how far you can jump from one path to another.
Yeah. He made a goose egg there, didn't he?
That was good. That
That
was
was
very
pretty
good.
Yeah.
Actually, no, because if you don't have the vertical ones, it's just gonna.
It'll just jump.
Yep.
There are parameters that say how things have to be and stuff.